Good morning, good afternoon, good evening. Welcome to our Salesforce Admins webinar, Programming Building Blocks for Admins. To teach you about these amazing programming building blocks, we have our amazing speakers, Kieran Jameson, Director of Trailhead Content Engineering here at Salesforce, and Angelica Morissetti, also on Team Trailhead as Senior Technical Writer. We're super excited to have them talk to us about programming building blocks and translate that for admins. But we do have some housekeeping before we get started. So we have our forward-looking statement, just reminding you to please make any purchasing decisions based on currently available features and functionality. And we want you to connect with us. We are where you are. We're on all the different social channels, and we're going to be tweeting about everything that's happening right now live. So join us at Salesforce Admins, no I, or find us on Facebook and LinkedIn, also as Salesforce Admins. And we also always post all of the webinar recordings from this program on YouTube, so you can find those there and find more resources and information on admin.salesforce.com. And before you ask, yes, we will be recording this webinar. So you can go back to the landing page where you registered to find the recording and also the slides. We'll be posting them in a couple of days. And the link to that is right down there. And we'd also really highly suggest that you ask questions throughout this webinar in the admin webinar group on the Trailblazer community. The bit.ly is right there. Remember to capitalize A, W, and G to get there. Don't wait until the end to ask your questions. Go ahead, post them in there. We will hopefully have a little bit of time to answer some live at the end, and we will join the group after the webinar to answer any other questions.
Great. Well, thank you so much, Rebecca. Angelica and I are thrilled to be here today to talk about one of our favorite topics. So let's dive in. What are we going to be covering today? We'll talk about some of the basic building blocks of coding on the Salesforce platform and how these concepts relate to the things that we know about the Salesforce environment. We'll show you how to recognize some of the coding best practices when you're back at your computer and are looking at the code in your org. And we'll leave you with some great resources to help you get started learning Apex after this session. We'll have some time for Q&A at the end, hopefully, and we'll likely probably not be able to answer all the questions, but we will be hanging out in the Trailblazer community, as Rebecca said, so post your questions there, and we will see you there afterwards. So, with every great presentation, there's a story, and our story revolves around a company that Angelica and I co-founded called BOTanical. We make robotic alternatives to traditional flowers, and we use the Salesforce org to automate our processes. So you'll see some things today in our presentations, but basically we're going to show you how we use the Salesforce org to trigger the creation of a new task when we define a top account for botanicals. So let's look at the object model before we dive into the actual code. We use this, two standard objects here, the account and the task object. Now we could also be using custom objects and fields, and if we did, if you saw an __C, that's your sign that we're looking at a custom object or a custom field. So let's check out some of our first building blocks, and that is classes, variables, and methods. So first, let's talk about classes. They're just the places or the file that we use to put all of the code that's going to run in our org. Inside classes, we have methods and variables. And methods is the part of the code that actually does the things that we want it to do. So things like creating a task. And there are variables, and we can think about them as storage containers. They're temporary fields in a way. And for example, they could store things like the status or the priority of a task. But there are any number of things that we could store as variables. So let's look at some of the ones that we could use for the account class. Things like the name of the account, whether the account is active, and how many employees the account has. You'll see that there are variables here that have values next to them. For example, employees has a value of 10. So classes have variables, and sometimes those variables have default values, just like fields in Salesforce have default values sometimes. And sometimes they have no default value. You can see here that we use the word null when there is no default value. So have a look at the parent ID variable and you'll see null next to it. Now let's check out the methods. These are the default actions that a class can take. So things like add to campaign, or one that we'll be working with throughout this presentation, calculate value, which automates creating an account, a task when an account reaches a certain value. So to sum up, we know that classes contain the code-based business logic in your org, and that classes have variables and methods. So let's look at how to create those classes, methods, and variables in code. So here's an example of code that we use to create a class. In this case, it's called account utility. First, we say what part of the org can access this class. This is your access modifier. In this case, the class is public, which means that all parts of the org can access this class. Next, we have the type of building block that we're creating, in this case, a class. And the last part of that first line names our class, account utility. Then we have two curly braces, and the contents of the class, the variables and the methods, go between the two curly braces. You can think of them as bookends for your class. Whenever we see two forward slashes, like we do here on line 2, those are code comments, and you want to see a bunch of that in your code when you go into your org, because that is going to be describing in plain language what your code is doing. Cool, so we've looked at how we would create the class. Let's look at some code that would live inside your class. So a reminder that methods control the behaviors of your class, and here you can see how we create a method. Again, we start with the access modifier, in this case public, just like the class. Don't worry too much about the void piece. It just signifies that we're not sending any data back to the code that's calling or using the method. Next, we name the method, in this case, calculate value. Then we have a beginning and end parentheses, and this is one of the signs that this piece of code that you're looking at is a method, because all methods have an open and closed parenthesis. If we're sending data to the method, then the data that the method will use, then we're going to put that in those parentheses, and you can see an example of this later. Then again, just like the class, we have an open and closed curly braces, and all the code that will run in the method will be between those braces. Awesome. So now we've seen how code in classes, variables, and methods work. Let's look at another variable type, and that is called an sObject. So in Salesforce, records are obviously core to what we do. We talked a little bit about variables in Apex, and because Salesforce records are so important, we have a special type of variable to store them, and this is called an sObject. sObjects hold a single record of data from a Salesforce org, like an account, order, or a task. You can see two different sObjects here that store different types of records. The account sObject is storing information about Ulceraf enterprises, and the task sObject is associated with that account and is holding all of the information about the task. Now we know that an sObject is a variable and that it stores an entire Salesforce record. Let's look at the variables that make up that sObject and store the data within that record. If you've ever created a task, then you know that there are multiple fields that you can add to the task object, from text fields to number fields, dates to checkboxes. Well, the same fields that you see in the UI are the variables that are associated with an sObject, in this case, the class sObject. And just like every field has a data type, so do variables. For example, in the Object Manager, we can create fields for text and URLs and phone numbers, emails, and picklist values. In Apex, all of these variables have a data type of string. Likewise, a checkbox is used to store whether something is true or false, on or off. And in this case, in the code, we call this data type a Boolean variable. And numbers, percent, currency fields, all of those are stored as integers or decimal variables. Dates and times are super easy to remember because they have the same data type in both Salesforce UI and in Apex. So now let's look at how we would create a task sObject in Apex. On the first line, we're creating a new task sObject variable, and we're naming that variable T. We're immediately setting some values for the variables within the task sObject. You can see them highlighted in yellow. Variables like what if, owner ID, subject status, and priority. These might look very familiar to you because they're the same developer or API names that we see in the Salesforce object in setup. One thing to note that at this point, our T sObject just lives in our code. It hasn't been saved to the database yet. We'll show you that later when we talk about DML. So Angelica, we've talked about classes, variables, methods, and sObjects. What's next on our tour of coding on the Salesforce platform?
Thank you, Karen. Well, now that we have a better understanding about all these different building blocks, how do we get all of this code working? So the answer to that is triggers. Triggers listen out for certain events to happen to records. For example, a record being inserted or updated or even deleted. Once the trigger recognizes that a record is being modified, the method that is created outside of the trigger runs. So triggers can be considered like the air traffic controllers of your code. It's the source that tells when to run certain pieces of code. When you're creating triggers, there are two best practices to think about. The first is to make sure that your triggers don't contain a bunch of business logic. This way you can reuse your code and it makes it much easier to understand. It can act like a table of contents for your code. The second best practice is just like you wouldn't have multiple processes running against a single object, you also wouldn't have multiple triggers listening to a single object. Otherwise, you can't control which order the actions fire. So let's take a look at how to create a trigger in Apex. First is the keyword trigger, and then the name of the trigger. This name can be anything you want it to be, but of course you want it to be something that's related to your code. For us, our trigger is called account trigger. And next is the word on, that doesn't change, and then the name of the object that you want your trigger to listen to. Ours is the Salesforce object account, but it can be really any object, even custom objects that your trigger can listen to. In the parentheses are the parameters. This is where you say when we want our trigger to run. It can be before or after the object is fired in an insert, an update, or delete. Here, after triggers, like what you see in this example, are great for doing something related to a record that you just inserted or updated in your Salesforce org. For example, if you're trying to create a series of related records, then you can do that very easily with a trigger. Before triggers are great at setting data programmatically before you save a record. They're also great for verifying that the data will actually work. It's nice because unlike validation rule formulas that you might be familiar with, they have limitations. So your trigger can validate based on any data that might be in your org, even the data that's in external systems. So now that we know that trigger is the building block that gets our code running, let's learn more about a few building blocks that will help our code run quickly and more efficiently. So the first one would be lists and for loops. So first, let's look at lists. When you heard me say the word list, your first thought may have been like a to-do list or a grocery list. And lists and Apex are very similar. There are groups of one type of thing that store together under one variable name. In this case, it's a group of tasks as objects called new tasks. In the first line of this code, we're creating a new list. It's empty and it's ready for new items to be added to it. On the second line of code, we're creating that new task as object to add to our list. And that same thing goes for any standard or custom as objects that you want to create. So next, we name our task T, and we assign T certain properties like we did earlier, like what ID or subject, or it can be any properties that are associated with the task object. Lists also come with a series of built-in methods like delete, size, clear, and add. So since we don't have anything in our new task list that we created at the beginning of our code, we want to be able to add our tasks. that we just created to our list. So to do this, we use the add method at the bottom of the screen that says new task.add, and then we put in the name of our new task that we just created inside the parentheses, which is T. So the next building block is for loops. For loops and lists, they work hand in hand. For loops are used to look through individual things in a list, and then they do something to each thing. So for example, we have our for loop. In the parentheses is the list called new accounts from trigger. And this is a list that the for loop is going to be looking at. So there might be one or more things in that list. And so once we look at that individual item, we give it a name. And the name that we're going to give each individual item is called current account. So, and then once we get to each individual item in the list, we look inside of our curly braces, and inside of that is actually doing something to that individual item. So if you're a bit uneasy about lists and for loops, so don't be discouraged. Let's pull out all of everything that we learned so far by taking a look at a snippet of code. So this might be similar to what you might see in your org today. Here we have our class, account utility, and inside of account utility is our method. This method is what we would be called in our trigger. So the name of the method is calculate value. If you remember, our trigger fires only after the account is updated. So right after the update happens, all of the record data associated with that update will be sent to the method calculate value. And then the data that gets added to a list, the data then gets added to a list called new accounts from trigger. So the first line that's highlighted in green is where we are creating a new list of tasks called new tasks. We're doing this because we want the code to be able to handle if one task are made or many tasks are made. Okay, and then in blue, we have our for account, which shows we have our list, new account from trigger, and we have our current account that's going through each individual item in the list. Inside of the for loop, we have our if statement. If you ever had, if you ever created an if statement in a formula field, you might be familiar with this if. And it's pretty much saying if the current account is set to top account, if it's actually top account, we're going to create this task inside of the if statement, just like we did previously. We're going to give it a what ID, we're going to give it a subject, and then we can also add our extra variables that are associated with our task. Once we verify that and we create our task, we're going to add the new task inside. We're going to add our new task inside of the new task list, and then that's it. We have our new task list. But we're missing something. We've created a new task, but this is equivalent to a user going into an org and filling in the data that they want and not pressing save. As Karen mentioned before, nothing has actually happened up to this point. And we want to be able to see what we're doing inside of our org. So to do this, let's figure that out and see what we need to do to be able to see what we're doing inside of our org. So to do that, we're using data manipulation language. So DML, also known as data manipulation language, is the way that we update data in our Salesforce org. It's pretty simple language with a keyword that says which DML action you want to perform. And the next identify which list of sObjects you want to perform the action on. In this case, our sObject is the new task list. Once the insert statement is run, new task records are created for all of our tasks that were added to the new task list. So in our code, we use the insert statement, as you can see at the bottom, that's highlighted in yellow. But that's not the only statement that's available for us to use. We can also use update, delete, assert, undelete, and merge. There's some other statements that you can be able to use. If you're interested in learning more about those DML statements, you can see additional examples on the Salesforce Developer Docs. All right, so let's check out some additional building blocks. Our last one, which is the SOQL, also known as Salesforce Object Query Language. So with SOQL, this is how you query your database. It's how you pull data out of it. And it's pretty simple structure with three parts. A select statement that identifies which fields you want to grab, the from statement that says which object contains these fields, and a where statement that contains all of the filters you want to use. This is very similar to creating a report, and just like in a report, you say which object you want to pull data from, what fields you want to display, and which filters you want to add. So now that we have an idea of SOQL and DML, let's talk about the two last concepts that are very important, which are governor limits and bulkification. Okay, so you may have heard the terms governor limits and bulkification, but let's talk about what they are and why should we actually care about them. So imagine your Salesforce org is an apartment in a large apartment complex. There are hundreds, maybe thousands of other apartments in this org, but only one very large hot water heater. Imagine there's one resident who took super long showers and used up all the hot water in the complex. The rest of the tenants, they're pretty angry. Well, that's a good analogy for your Salesforce org and how it resides in the Salesforce pod containing many, many other Salesforce orgs. Each time you use SOQL or DML, you use up those resources, and a little bit of that hot water runs out. But Salesforce is smart. They're not going to let one Salesforce org use up all the hot water. They're going to limit what you can use in any given transaction. These are your governor limits. They limit how many SOQL and DML statements you can use at one time. But you might be doing big bulk updates to your org. So how do you do this when you can only use 150 DML statements in a single transaction? So that's where bulkification comes in. Bulkification, which we'll look at in a minute, is a way of coding for efficiency. It basically means that instead of sending out all new sObject records to Salesforce one at a time, you'll create a container called a list. And we're gonna put all the sObjects in it and then send the container up to Salesforce using that one DML statement. This is bulkifying your code. This is what we want to do. So let's go back to our Apex code that we've been looking at and see how we can incorporate DML and better understand how bulkification works. So here we have our account utility class, remember, with the calculate value method. It's pulling all of the data that's associated with the update that happened when our trigger fired into that new accounts from trigger list. And in the first blue highlighted section, our for loop looks at each individual account in the new accounts from trigger list. Inside the for loop is the if statement that's doing an action. It's saying if the current account is a top account, create a brand new task. That task is then added to the new task list that we created at the beginning of the method. And once all of the accounts in the new accounts from trigger list have been evaluated, the for loop is completely finished and we can insert that new task list all at one time using a DML insert statement in green that you see at the bottom. You may be wondering what was the purpose of creating the new task list and then inserting it afterwards. Couldn't we use the insert statement inside of our for loop to insert the task as we go? Well, just like we were speaking about earlier, we always want to make sure that our code is bulkified. If there are hundreds of tasks, there's possibility that we would exceed those governor limits if we inserted a task each time the top account checkbox was checked. We don't want to do that. Instead, we create a list that will keep track of all the changes as we go through our for loop. And then once all the accounts have been processed and tasks have been created, we store that in that new task list, and then we send or insert that list of tasks all at once. So that way we don't have to worry about those governor limits. So bottom line, no SOQL or DML in for loops. Got it? All right. Okay, so let's wrap this up. What exactly did we learn? So utility classes store all your business logic. They contain things like variables, methods, loops, DML, and SOQL. Variables are like temporary fields. They can be as simple as a string or as complex as a list. Or sObject. sObjects are variables that store an entire Salesforce record. And lists are variables that store groups of simple or complex variables. Methods are what contain all of the action. They make things happen. And for loops take a list and do something to each member or item of that list. Triggers listen to changes to your database and then fire off methods within the class. And SOQL queries your Salesforce org for data, and DML saves data to Salesforce. Bulkification, last but not least, ensures that your code will run when you're working with one record or when you're working with many records. If you wanted to learn more about Apex, please check out our new trail, Build Apex Coding Skills. They contain some hands-on challenges that you can be able to use to learn and just play around with Apex yourself. We also encourage you to join a community group in your local community, or even if you're remote, there's some available for you as well. We also have our TDX presentation recording that you can be able to use to see our code running live if you want to play around with it or follow along with us as well. Check out the websites for our women. It's at DC99, Women Code Heroes, and Arch Ladies if you're interested in learning more and getting more involved. Thanks, Al.
Thank you, Angelica and Kieran. I can't believe we just went over 8 building blocks in the 30 minutes. It was amazing to hear about all of that. Just to remind you all, we are taking questions in the admin webinar group. There will also be a survey that pops up at the end of the webinar that we'd love for you to answer, and we'll be posting slides and recording at that bit.ly. We do have some time for questions, and I think I want to kick it off with I think a little bit more of a broader question. You know, as admins, we know the power of clicks and using that to kind of automate things and customize. So how should we approach like when we should use code instead?
I can take a stab at that. It's a question that comes up a lot. And in general, the general rule is that if you can click, you should. So you want to use all of your declarative tools before you dip into your code toolbox. There are some times when, for example, you can't use Process Builder, for example, when you want to delete things and things like that, or when your processes start to get really unwieldy and you're having to really work around the edge cases of your declarative tools, then it might be worthwhile getting into code. Some other examples of when it's good to get into code is if you're doing complex validations that require pulling data from different objects that aren't necessarily related to the one that you're working on now, or if you're pulling data from externally, that's another good time to use code. So, the general rule again, just to state it again, is that you use clicks if you can, generally, or when it becomes unwieldy. Then if it's not possible to use clicks, or if it becomes really unwieldy to use clicks and your code is all over, your business logic is all over the place, then it's helpful to get into code.
Great, thank you. I see there are some other questions in the community that we're answering, but we'd love to hear. I think the latest question was about the loops, avoiding loops in governor limits in SOQL and DML if we need to iterate a method over many records.
Yeah, so there are some patterns, and I'll link to those patterns in afterwards, but there are ways of getting around this. So one of the things that you can do is you can use SOQL to populate another kind of container variable. So lists is called a collection, or is part of a collection, and there are 3 types of collections in Salesforce. There's lists, sets, and maps. And so maps are really helpful because they help you really quickly store the ID for a record and then the entire Salesforce record. And so you can use SOQL to populate a map, and then you can loop over the map inside SOQL. So you keep the SOQL outside of the loop, but then you use that SOQL to populate a map that then you can use within the loop. Does that make sense? So there are various patterns to work around that. I'll find a good link and post it in the chat.
Amazing. Thank you so much, Kieran and Angelica. This was super informative. We love having you on the admin webinar program, and we will be posting everything and in the community answering questions after this. Thanks everyone for joining us this morning for our webinar. Goodbye.
Thank you all.
Bye.